What's up, everyone? This is Dr. Jax. Today, we're going to look at how to use the angle of incidence and angle of refraction to calculate the index of refraction for an unknown substance. Today, what you're going to see is as the laser light is rotating on this piece of wood, you will see a protractor that allows us to measure the angle of incidence and angle of refraction from the normal. As the angle changes, we can use both angles and the slope of a graph that we're going to create, where we take the sine of the first angle and compare it to the sine of the second angle, and use that based on Snell's law to calculate the index of refraction for the unknown substance. Now, what you'll notice is as the wheel turns, the angles change from the angle of incidence to angle of refraction. And because the light is passing from a less dense material, air, which has an index of 1, to a more dense material, you will see that the light bends towards the normal. This is what we should expect to see. And as we adjust for each different angle of incidence, we can then use the changes in the angle of refraction to calculate the material. So let's watch. The first time we're going to look at this in slow-mo, we're using some spray mist to see the laser as it's passing through. All right, and you'll notice that as it passes through the normal on either side, you get the same effect. The second time we watch it through, we'll do the same thing, but we'll pause at different angles so that you can measure the changes in angle of incidence and angle of refraction. So here, if you notice one more time through, what I'll do is pause it at various angles, and you can see that the angle of incidence is always greater than the angle of refraction because it's passing into a more dense substance. And you'll see the same effect on the other side. Now, it doesn't matter which side you use for your calculations since the normal is perpendicular to the surface on either side.